We were creating a low-cost battery cycler and cell emulator. It's a proof of concept design for this part. And it incorporates a high precision DAC and ADC, that's digital analog converter and analog digital converter. And this prototype is we're doing a low-cost alternative for a battery testing equipment, and the battery testing equipment normally costs thousands and thousands of dollars. So we're trying to miniaturize this a little bit and make it a little bit cost-friendly for people. The goal for this one was combining an MPU, DAC, and ADAC with 3 amp max op amp that can charge and discharge a cell using simple commands.
What we needed the program to do, like we were talking about, the project itself is a battery cycler. So we need the chip to interface with a circuit that will then charge a battery and also watch the discharge of the battery. The goal, some of the features of the code of the program that were requested were that an input script file could be used to have predetermined charge cycling and user input values to then control the output from the chip. And then within a cycle, there are different modes that might be utilized, sometimes a combination, sometimes just one or the other during the charge cycle. And so those charge cycles govern a lot of what the programming has to account for. The first mode that I'll talk about is the current controlled mode, which requires the chip to measure the current output from the chip into the circuit, and then adjust the output from the chip to keep that current steady until we reach a point where we want to change to voltage control. Now, in voltage control, we want to measure the voltage output from the chip and adjust the output from the chip. And then the chip will then see what the value of the voltage it's at, and if it's changing, we want to make sure it's staying steady since it's voltage controlled, keeping a constant voltage. We'll adjust the output from the chip to then keep that voltage at the same level. The next slide shows the problems that we faced as far as programming goes. At first, we wanted to use a different programming software called Platform.io, a plugin to Visual Studio Code to talk to the chip that we chose, but it turned out that it's not very easily configurable to do that. But luckily, the developers, the people who manufacture the chip, actually have their own software that they use for programming the chip that we were able to use. But that documentation for that program was the next problem that we faced. There was a steep learning curve, almost like a completely different library of functions to learn. And the solution that we had to this was to look on their website for different examples and analyze those examples and understand how those work to then understand how we can use that programming software for our own project. Then another project that we faced very late on in the development was when we populated our circuit board with the parts and the chip. We would then needed to upload code that we had designed onto the chip to then run with the circuit. And unfortunately, we weren't able to get the chip to be recognized by the computer when we connected it through USB on our populated board. But the way that we wanted to test, we needed to test our circuit board after we populated it. And so a way to get around this inability to communicate was to just use I/O connections from a development kit that we got from the manufacturer and connect those two leads on our circuit board just to test it. And that helped us verify that our circuit board was working correctly after we had soldered everything on and populated it. And then the final problem that we faced was that USB communications to the PC, to the computer, for a script to get the script onto the chip and to get data back from the chip. We weren't able to get to that. And so that's one of the last problems that we faced. We were able to write code that demonstrates the following aspects of our project. We were able to get the digital to analog converters, the DACs, inside of the chip to output expected values that the circuit was going to be using. And then we were also able to show that using the op amps to switch between different control modes, we could verify, and that's shown by this picture right here. This diagram is showing switching from one mode, which is the higher, the line going on the top, and then the low mode is the bottom line, and that's showing a switch between current controlled and voltage controlled nodes. And then we also were able to get code that read the input from the circuit through the analog to digital converter.